Hello students and welcome back to Mechanical Engineering Practice and Graphics. Today we will be covering the chapter 13 of the book, Assembly Modeling, second part. We are in the week number 11 and this week we have a couple of activities. The first one is that we have homework number 8 and also the part number 4 for the final project. Remember that next week, in week 12, we have the fourth and last quiz of the semester, and that is going to be held on Monday. Remember that each student must submit 5 parts for the final project, and that each of these 5 parts must have at least 3 different features. As I already said, this week we will be submitting the fourth of these 5 parts. Remember to submit both the PDF and the Solidworks part file. Next week quiz is not gonna be proctored, so you don't have to connect to WebEx. I will be submitting the blueprint next Monday, and then you will have 24 hours to complete your quiz, which means you will have to submit your files on Tuesday. Now for this week, I'm gonna introduce the homework. I'm gonna help you in the first part, and then you will have to complete it by yourself and submit it by this Sunday. For this one, since we're gonna be doing an assembly, and in order for the assembly to work when I open it, when I am grading you, I will need you to submit a complete compressed folder. Now in this compressed folder, it can be either with file extension zip, or you can use file extension rar. Either one will work. Now what I need you to include in the compressed folder is the following. I'm gonna provide to you some part files. They are already done. But what you're gonna do is you're gonna put all of them together in an assembly file. And then you're gonna take a screenshot of that assembly and paste them in a PDF file. Everything must be in the same folder, and then you compress this folder, and that's what you're gonna be submitting to Blackboard this week. Now, the parts that I'm providing to you are this piston, this articulated rod, this master rod, and a couple of minor components. All of these are going to be provided in Blackboard in a compressed folder with file extension rar. I will need you to download this and uncompress the folder, and then you can use these parts towards your assembly. Now if you have problems downloading this file, here are the blueprints for all the parts that you will be using during this assembly, and then you can model them by yourself. Now the objective of this homework is not for you to model these components, is for you to assemble all of these different components into one final assembly. So I'm going to show you in Blackboard. The parts will be in my folder in week 11. Now at the time that I'm recording this video, there are some memory issues in Blackboard, and that's why we have here invalid file, but you will find there the radial engine provided parts. Now if you click there, it will ask you to download a file, which is this one. I already downloaded this. So you just have to click extract here, right click on that, and then extract here, and then you will have this folder with all of these different components in it. Since I'm gonna do this in the class, I have a different folder for that. So let's get started. Now the assembly that you will be doing today is this radial engine. As you see, we have 10 different items, and some of them we have to use them many times. So what I'm gonna do is I'm gonna teach you how to do a subassembly and then how we can import that subassembly inside another assembly. So this is the radial engine, this is the view and explosion. It means that all of these different components go inside the piston, and then the piston is attached to the rods, and each of these rods are attached to the master rod. I will need you, when you submit the assembly to Blackboard, to respect these angles that I am highlighting here. And the final assembly should look like something like this. Right, let's get started. Now in Solidworks, I'm gonna create a new assembly. And in this assembly, what I'm gonna have to change the location in class practice. I'm gonna use first the piston. And just click OK. Okay. Now I'm gonna insert the rings, piston ring. Okay, and then I'm gonna use mate relation to define a relation between that circle and this other cylinder. And then this one should be in contact to this face. That's okay. Now we will need a couple of these, 1, 2, and 3 more. So I'm just gonna press and hold Control key in my keyboard and then just drag them. That's better. The same for all of these. Okay, we have a piston with all of the rings in there. Now we have to import the part 5, which is the piston pin. So we look for the piston pin, it's here. And then we're gonna add this relation here. Now as you see, this one should go inside there. And since I want the same distance at both sides, I'm gonna measure now. In evaluate, I can use the measure to measure the length of this pin, which is 80 millimeters, and then this other distance from here to here, which is 84. Now since I want this to be perfectly in the center. I know that I need 2 millimeters here and then 2 more millimeters here. Okay. This face and this face, they are parallel at 2 millimeters, and that's okay. So we have 2 millimeters here and 2 millimeters here. If you are unsure of this, we can evaluate again. The distance between these two faces is 2 millimeters, and the same at the other side. Okay. Alright, we have that pin inside the piston, and then we need two number 6, which is the piston pin plug. So let's look for that one. Piston pin plug, and we need two of these. So I'm gonna do a copy, pressing and holding Control key in my keyboard, and then we have that. Now this one, it's coincident to this one, and this surface is in contact to this other surface, like that, and the same in the other side. I'm gonna undo that one. First I'm gonna move this one here, and then I'm gonna do that relation. Okay, and then this surface and this surface. Okay. Follow by, now we can insert the rod itself, the number 8 articulated rod. No, sorry, first we need this part here, which is the number 3. And the number 3 is the rod bush upper, which goes in here. Insert components, rod bush upper. Okay, here is fine, and then a concentric relation there. Again, we need to know exactly where the center is, so I'm gonna measure that one. Evaluate, measure. From this face to this other face. We have 42 millimeters. If you don't want to measure, you can always come and see in the blueprints. And this one is 42. Okay. And this other one was 84. So I'm gonna add a relation here between this one and that one. They both are parallel. 84 minus 42 is 42 as well, and half of that is 21. Yeah, we need 21. Okay, if we want to make sure, we can again measure that between this face and this face. We have 21, and we can do the same on the other side. This face and this face, also 21. Okay, this is correct. We have that bush there, and then we can import the rod, articulated rod. So for this one, I'm gonna define coincident relation here, but then this can still move. And these two faces should be coincident, and then click OK. And the same happens at the other side. So we have that, and then we can move the piston like this. Now these pistons at the other end, they have another bush, which would be the number 9, which is rod bush lower, and then we can insert that one. We add the relation there between those two cylinders, and then the two faces as well, this face and this face. They are coincident, and then we can click OK. Okay, so this is a subassembly, and we can use 5 of these subassemblies in the big assembly. As you see, there is only one master rod with the piston and everything. And then all these other subassemblies are added to that master rod. So I'm gonna save this assembly, save as. I'm gonna call this subassembly 1. Okay. And then I'm gonna create a new, actually I'm gonna create a new assembly file. And in this assembly I'm gonna start by using the master rod. Okay, and then what I'm gonna do is I'm gonna insert that subassembly that I just created, this one. And I know that I will need 5 of these. So I'm gonna copy, control. It doesn't work with assembly, or maybe it does. Let me see. No, it doesn't work. So we will have to import 5 times this subassembly. Sorry, not 5, only 4 times. Okay. And then I'm gonna add a relation, let's suppose for the first one. You will do the same for the other ones. Like that. And then this face should be in contact to this face. And we're missing a bolt here. This pin. So we use the mate relation to align the pin the other direction. and then we use this surface must be in contact to this surface, and that's it. So you will have to do the same for the other components. I'm gonna delete these three. So you will have to do the same for the other uh, three sub-assemblies, and then assembly the piston here as we did before here. Maybe I am missing one last relation here, which would be this angle between this surface and this surface. That angle would be here 75 degrees. That should be it. You will have to do the other ones and then submit everything. Now to save this, I'm gonna call this save as, then lecture 2 ABC123. Use your own. In my case, it would be LJK354. And then homework 8. And then I have the Solidworks assembly in the type of the file. So I can just click save. And I'm gonna exit all of this just to show you how you can compress this folder. Remember that I was working in the in-class practice. So I just right click on that one and then I click in add to in class practice.rar, and this will be the file that I will have to submit to Blackboard. This is a compressed folder. Okay students, I think that's all for this tutorial. I guess this was a very short tutorial, but it's just the homework. You will have to complete this assembly. Please let me know if there are any questions. Remember that we have the quiz next week on Monday. It will be also a assembly. I probably will provide the parts for you. Remember to submit the part number 4 for your final project. And I guess that's it. Thank you very much for watching the tutorial, and see you next week.